about some characteristics of exponential functions. Again, the good news is many of these characteristics follow the same rules and are written very similar to what we learned in quadratic functions and even what we learned a little bit in linear functions. Okay? Remember, domain is all of your x values. And since we graph with two arrows, we are still talking about all my numbers, negative infinity to positive infinity. My range is still going to go from bottom to top. So I want you to write yourself a reminder. You're going from the bottom of your graph to the top. So there's a couple of options that we have here, okay? If we have a graph opened up like this or like this, my range is from my asymptote to infinity. If my graphs are being reflected like this or like this, I'm now going to go from negative infinity up to my asymptote. So let's look at graph number 1. We know that my domain should still be negative infinity to positive infinity. I know that these arrows are telling me to talk about every x value from left to right. Now my range is from my asymptote, and I know I have an asymptote because my graph will flatten out. Okay, so this asymptote is at 0. Well, that asymptote is the absolute lowest part of my graph, and I'm going to go all the way up to the highest part, which is an arrow. So this is going to be positive infinity. Now, let's try another one. This is one of the reflected graphs, so we need to look at the information here. My domain will still be negative infinity to positive infinity. But now, look at what's at the bottom of my graph. It's pointing down towards all my negative y values. So we represent that with a negative infinity. My graph is going to flatten out right here, and that's a y value of 3. There are 2 more examples at the bottom that I will definitely show you at the end of the video. I encourage you to pause now and try them. We can still talk about our intercepts. Okay, remember when we have a y-intercept, that's where the graph crosses the y-axis, and so we write it as an ordered pair, 0, comma, whatever that y value is. My x-intercepts is where the graph crosses the x-axis, so I'm going to write an ordered pair as x, comma, 0. Whatever this x value is, my y value will have to be 0 if I'm on the x-axis. And we don't need to worry about zeros. That's more in quadratics. So let's identify them. My y-intercept is right here where it crosses the y-axis, and that's at a y value of 1. X-intercepts. Well, notice this, my asymptote is the x-axis. So can my graph ever cross it? No. So x-intercepts are going to occur on one occasion. If my graph is moved down, or I have a reflection and it's moved up. Okay, so right now there is none. It will never cross that y-axis because of my asymptote. So let's look at graph number 2. Okay. My y-intercept, again, is where it crosses the y-axis here. That's going to be at 0, 1. Now, I do have an x-intercept. It's right here, but it's not on a perfect point. So we can either make an estimate, or you can tell me, you know what, Miss Walsh, it's just going to be a fraction. Try those two examples at the bottom. Again, the answers will be at the end of the video. Maximums and minimums. There is not truly a max or a min. There's not truly a maximum because this arrow, I don't know where it ends. I don't have a maximum point. This is infinities, which cannot be a maximum. Okay? My asymptote is at y equals 0, but I never actually touch this line. I never actually get to y equaling 0. So what we're going to talk about is it approaching a maximum or approaching a minimum. This graph is approaching, and I'm just going to abbreviate it, appro. It's approaching a minimum at y equals 0. In graph number 2, this minimum is a negative infinity, but infinities can't be minimums. But my asymptote up here tells me that my graph is approaching a maximum at y equals 3. So when we think about max and minimums up here, I'm just going to write a blanket statement. We are approaching one of these, and we're still going to write it as a y value. You can't truly be there, but you're just going to approach it. Let's talk about asymptotes. Your asymptote is let's choose a different color here, shall we? Your asymptote is your y equals k. Okay, it's the k value of your standard form equation. Well, on our graphs here, again, it's just where this graph, my exponential function, is going to flatten out. So that's y equals 0. And up here, it's going to be where y equals 3. Go ahead and pause it, try these last two examples, and you can check your work at the end of the video. A few more. Intervals of increasing and decreasing. Okay? We're not going to truly write an interval. It's more of a question. Am I increasing or am I decreasing? So my interval of increase depends on my slope. This has a positive curve, so that's an increasing interval. Okay. When my graph is flipped upside down like this, I have to think of this. You should be asking yourself this question. As my x values increase, what are my y values doing? Okay, and what I mean by this is as I increase in x values, is my graph increasing? Am I creating a positive slope? In this one, the answer is yes again. Okay, yes, I have an increasing interval. We are not going to talk about the interval of constant. You don't have to worry about that. Okay, let's talk about end behavior. End behavior, remember, is what's happening at the end of our graph. Remember, in quadratics, we were lucky enough to have two of the same end behaviors. Well, now, that's not going to be the case. We have two types of end behaviors that we could talk about. We could talk about when my graph is opened up or when it's falling down just like this. Okay, so in green, I'm going to talk about these two cases. In green, okay, well, let's label them. I lied to you. This first example, my growth function. When my x values are negative, my y values are approaching my asymptote. When my x values become more and more positive, I'm approaching infinity. We have two different ones right now. In this graph example here, when my x values are negative, I'm headed towards infinity. And as I'm falling down my graph and heading towards positive x values, I'm now reaching my asymptote. Now there's two other examples. Let's pick a different color. Okay. What if these graphs get reflected? So what if I have this picture or I have this picture? So this example 3 here, as my x values get more and more negative, I'm still approaching my asymptote. And as my x values get more and more positive, I'm headed towards negative infinity now. This arrow is being pointed down. Okay. Make sure you notice my different colors for these examples. Okay. I know there's several things going on, but notice the colors and the labeling here. In this fourth one, when my x values are negative, I am pointing negative. And when my x values are becoming positive, I'm now reaching my asymptote. So you can notice that I'm either talking about a positive or a negative infinity, or I'm talking about my asymptote. So let's look at these examples here. When I'm talking about a negative x value, that is this area right here. Okay, those are negative x values. My graph is approaching my asymptote, which is at 0. Now, when I go over here and I talk about my positive x values, this arrow, this part of my graph, is headed towards positive infinity. Again, let's look at this example. Negative x values, that goes with this first one. Where is this arrow headed towards? It's headed towards negative y values. Then, my positive x values are here, but this arrow is flattening out at my asymptote, which is at 3. The last characteristic we have is rate of change, but we will talk about that more in class. I want you to focus on mastering these characteristics. So now, I will slowly go through the answers for each of the remaining examples. These are the domain and range answers. These are the x and y intercept answers. These are the maximum and the minimum answers. These are your interval of increase or decrease answers. And your end behavior answers. Again, we'll pick up with rate of change in class. Be prepared.